In this section, we're going to take a look at behavior-driven design. We're going to explore what is BDD and why BDD. Then we'll look at a simple given when then example, and then an extended example, and then we'll take a look at some asserts. First, what is BDD and why BDD? We'll look in this video at the history of BDD, the focus of BDD, relation to the specification documents that we're going to create with our business analysts, programmers, and testers alike. And finally, we'll consider some acceptance criteria. So first, a history of BDD. This emerged from test-driven development. We have the advantages of test-driven development where we consider behavior first before we write code, and then we consider the code complete only when the tests pass. But we add to this a ubiquitous language. And what do we mean by that? We mean a language that everybody can understand so that we're all talking about the same thing. We all understand what we mean when we say what an application should do so that there are not any surprises at the end of our development cycle or the end of our sprint when software is delivered. This will have a natural language and use words that we're used to, like given when then, and as a user, I expect something to happen. The nice thing about this ubiquitous language is we can go from a specification document that a business analyst might write all the way down to an example that a developer will understand, and then the developer will be able to make a test from that example. The nice thing about having everybody understand from end to end is that we break down organizational boundaries by having these autonomous teams that all work together. The same benefits that we see from co-location. We want to think in terms of behaviors and examples. We don't want to think in terms of tests. When we think tests, we think, well, wait a minute, QA does that, and QA is located somewhere else. I'm not going to worry about it. But when we think example, we think, this is how the software should work, and I'm going to write a test that verifies that the software works this way. Dan North is considered the founder or the author of behavior-driven design, and we'll see his quotes in a lot of the foundations that form behavior-driven design. As a matter of fact, from behaviordriven.org, we have 3 core principles of behavior-driven design. Business and technology should refer to the same system in the same way, or the short version is, it's all behavior. Any system should have an identified, verifiable value to the business. Where the business value? Upfront analysis, design, and planning all have diminishing return. Enough is enough. Once again, this is not necessarily part of Scrum, but fits well with Scrum, where we have the idea that we want to do analysis, we want to do design, we want to do documentation, but we prefer quick sprints, quick iterations where we can see results and verify that those results are what we want before we write a humongous document, or instead of writing a humongous document that says, this is what the software should do, now spend 2 years writing to this document. The problem with that is, over the 2 years of writing the software, the requirements are likely to change, and even the environment is likely to change. So when we think of behavior-driven design focus, we can think of what, where, when, and why, the words that we often think about when we ask, what is something doing? Behavior-driven design says, where do we start? What do we test? How much do we test? What do we name the test? And why would a test fail? Would a test fail because something was not written properly? Or would a test fail because the test was not written properly? These are the things we'll consider when we consider behavior-driven design. Now, let's think about this ubiquitous language and the relation to specifications. BDD is an integral part of technical documentation. We'll start with a business analyst writing behavior in this syntax. As a user, or maybe as a customer, or as an administrator, so the first blank there is a role. I want to take some action so that I will get the expected outcome. So the business analyst will start with this phrase. Then we'll meet with the developers and the testers and we'll say, okay, let's come up with some examples, some specific examples that elaborate those behaviors. Given some context or assumption, when an action happens, then I get these expected results. So the given when then is a more granular or fine-tuned version of the behavior that the business analyst wrote. Typically, one behavior will result in several given when then steps. We use these words that have meaning to everybody so that the business analysts, the developers, the quality analysts all have a role from beginning to end. It's not a matter of, oh, I don't need to be in this meeting because this isn't important to me. Now, everybody's going to have a role. Everybody's going to collaborate in creating the software. If we use the word example with given when then instead of test, it embraces this combined ownership of the test. When we say test, we tend to think QA does that, but when we say example, it means we can all think of how somebody would use this. Now, when we're writing our tests, we're typically going to write verbose method names that begin with verbs, like should pass if we have correct criteria, should pass if we have a valid search result, something like that, or should fail if we're not connected to the network. So let's take a look at a documentation example. I have a quick requirements document, Search for Plants. It starts with a scenario that was written by a business analyst. As a user interested in plants, I want to be able to search plants based on any part of the name, genus, species, cultivar, or common name. Dependencies. Plant search data are available and accessible. Assumptions. Scientific names are stated in Latin. That's the genus, species, and oftentimes the cultivar as well. Common names are stated in English, as is common in the English-speaking world. So, we start with these behaviors, and now we're going to break them down into examples. And examples are going to serve as the given when then that we will eventually use to create our behavior-driven design tests. So example 1.1, given a feed of plant data is available, when I search for a redbud, then I should receive at least one result with these attributes. Genus Cercis, species Canadensis, and common is eastern redbud. Okay, example number 2. Given a feed of plant data is available. Now notice that's the same given we have in example 1.1, and that's good, because when we use this given when then syntax, we'll see that we end up developing a series of subassemblies. And these subassemblies can be put together to make more tests with little effort. So given a feed of plant data is available, when I search for Quercus, then I should receive at least one result with these attributes. Quercus robur, English oak, and I should receive at least one result with these attributes. Quercus alba, white oak. So you see, in this case, we have two different then statements that we're combining together with an and that's perfectly acceptable. Now, if you're not familiar with genus of plants, Quercus is the genus for oak. And so there are likely to be many return values if we search for Quercus. But English oak and white oak are two very common oaks, so we would expect that we should see that if we have a feed of plant data that has a relatively large number of results. So that's part of our assumptions, that we have a feed of plant data available. Let's continue on with a slightly different example. Let's look at example 1.3. Given a feed of plant data is available, when I search for gibberish, this gibberish includes a semicolon, and a semicolon is not a legal character in a plant name. So that should return an empty list. So then we have, then I should receive 0 results or an empty list. But note that we also don't say that the program should crash. So there's an assumption here that we receive 0 results and the program continues to run. So we start with the scenario, dependencies, and assumptions that were written collaboratively with a BA, a QA, and a developer. And then using that, we create 3 specific examples that elaborate those assumptions. Finally, we have a sign-off from a business analyst with a customer, a different business analyst with a software company, project manager, quality manager, and a lead developer. And this emphasizes that this behavior-driven design vernacular that we're using is a ubiquitous language. It's one that we all speak. Finally, we have a revision history. On the 15th of December, I created the document. If we made any amendments, we might place those down here as well.
When we look at this document, we see it's only really 2 pages long. It's not a very long document. And this embodies the Scrum principle that we like documentation, but we like working software better. So in other words, we would rather spend our time writing a short document and more time writing maybe a prototype that someone can see, feel, and give feedback on, than spending that time writing a 36-page document that takes a lot of time to write and frankly nobody's going to read, and the time we spend writing that is taking time away from when we can build a prototype that someone can see and give us feedback on.
So that is a look at behavior-driven development